we're going to look at one application of exponential functions here, and that's compound interest. And we're going to give it to you here just so you know why we even care about exponential functions. And then in the next section of the unit, we'll do even more applications. So what we're talking about here is interest. And think about either in a bank account, or if you have credit card, you might have interest on that. So here's our formula for compound interest. What compound interest means is, so you have money in a bank account and you earn interest on it. And then when they compound it, what that means is you now earn interest on that new interest, and that becomes part of your bank account. And so now you have the original amount plus interest. When they compound it again, they'll add interest on that whole amount. Okay? So here's our formula. A equals P times 1 plus R over N raised to the NT. So that's where you see the exponential part comes in. We have that N and the T in our exponent. And here, A is the amount in the account. So we might say, like, after 5 years, how much is in the account. Okay, so that's the A here. P is what's called the principal, and that's how much you start with. The amount that you either deposited in the account, or it might be your credit card balance, whatever you're starting with. R here is going to be your interest rate. Oops, got a little too far on there, but R is going to be the interest rate, and we'll want to put that in as a decimal. Okay, N is the number of times it's compounded per year. So that's kind of how many times per year are they adding interest to the amount in your bank account. And then T is the number of years. Okay, so we'll call this A of T. T will be like our X. I'm going to erase that circle just because it might get confusing. Okay, so here it says, suppose that $10,000 is invested at 4.5% compounded quarterly. Okay, so let's first talk about what all of this means. So $10,000, that's how much that's invested, originally deposited. That's going to be our principal. The 4.5, that's our interest rate, but we need to turn that into a decimal. So we're going to move the decimal point 2 places to the left, so R is 0.045. The other thing we're told is that's compounded quarterly. Well, quarterly means 4 times a year. So N here is going to be 4. Okay, so 1 says write a function for the amount in the account after T years. So that means we need to fill in P, R, and N. We'll leave T as our variable. So here we have the amount after T years. Our P is $10,000. 1 plus R over N, so 0.045 over 4 raised to the 4 times T. And the only thing we can kind of do to simplify this is what's inside the parentheses. So we can do 1 plus 0.045 divided by 4. And we can write this as 1.01125 to the 4t. Now, we can't multiply the 10,000 by that because in the order of operations, you have to do exponents first. So we need to leave that exponent on there and leave the 10,000 out in front. So next it says, graph the function on your calculator, and it gives us a window. So we're going to go here and we're going to put in 10,000, 1.01125 raised to the 4, here it'll be x, make sure you put that in parentheses. Okay, we're going to go to our window and we're going to change it to 0, 25, it tells us to make our x scale 5, and 10,000, $30,000, and our y scale of 2,500. Okay, so here's our graph. We can see that our bank account is growing. So we're not saying we're putting any more in our bank account. We're saying that the interest is adding to our bank account. Okay, and just kind of notice this is what's happening over a total of 25 years. Okay, and you can see it goes off the screen, and our maximum here was 30,000. So over 25 years, it's gone from 10,000 to over 30,000. So this says find A of 5. Well, that means you would plug in 5 to here. So that would be 10,000, 1.01125 to the 4 times 5, or to the 20th power. And what this is saying is how much would be in your account after 20 years. Now, our calculator, since we have that in our y equals, we can use our table function and go down to 5 and see that after 5 years we would have $12,508. Okay, A of 10 would be how much we have in our account after 10 years, and we see that that's 15,644. And 20, so we want to go down to 20. We would have $24,473. Okay, so in 20 years, we've more than doubled the initial investment. Okay, next says, when will the account reach $28,000? So what we're going to do in Y2, we're going to put 28,000. And we're going to look at the graph. We're interested in the intersection. We want the X value of that intersection. So remember, to get the intersection, you're going to hit second calc, and number 5 is intersect. And it's going to ask you, are you on the first curve? Say yes, hit enter. Second curve, hit enter. It's going to ask for a guess, but you can just hit enter again. It's thinking, okay. And here, if we round to the nearest year round, we'd see that in about 23 years, it reaches $28,000.